Let's look at this problem. This is from chapter 3. Chapter 3, we learned probability. So you're expected to know how to find the probability, from an event by using the fundamental counting principle, or it could be a probability from the frequency distribution. So this problem, it's the counting principle. You're given a restaurant offers a $12 dinner special that has 6 choices for appetizer, 11 choices for entree, and 5 for dessert. So you can use the fundamental counting principle. How many different meals are available will be 6 times 11 times 5. So it's 330, and that's the answer, because we just count how many ways one event can happen times how many ways the other event can occur. It's like a sequence. Appetizer 6 ways, entree 11 ways, and the dessert 5 ways. So that's how you figure out this problem. And then let's look at the other one. Okay, this problem we can use the same way. The code. So the code has 4 digits. The first cannot be 2, and the last must be odd. And there will be 9 options for the first one, because from 0 to 9, 10 numbers, but it cannot be 2. There'll be 9 options, and be 10 options here, 10 options here, and the odd number could be 1, 3, 5, 7, 9. So it'll be 5 options, and just multiply them together. So it's like a fundamental counting principle, same thing. So 4,500. Okay, so this problem, it's the same problem, still counting. 5 questions, which means we have 5 questions, and each one has 5 choices. So it'll be 5, 5, 5, 5, 5. So 5 times 5 times 5 times 5 times 5. These are how many ways the quiz can be answered. So it's still a fundamental counting principle problem. And you can use your calculator to see what's the 5 times 5 times 5. So it's 5 to the power of 5, basically. Okay, so it's 3125 options. Ways. Okay, sorry. The quiz can be cancelled. Can be answered. Okay, this probability is based on a survey result. So it's actually just the relative frequency. To find the probability that the next person surveyed is very prepared, it's equal to the number of people who are very prepared, which is 252, divided by the total number of people surveyed. So you have to figure out how many people total, just add all together. Okay, I don't have enough space, so I'll write here. So this probability is just like a relative frequency. You use the number very prepared, divide by total. Okay, if you use your calculator, the denominator is 2212 if you add all together, and then the probability should be 0.114. So that's the answer for this problem. Okay, let's find how many codes first. So we have 3 digits, and the first one anyone can be 1 to 9, so it'll be 9 options. 9 options, 9 options. So it's 9 times 9 times 9, which is 9 cubed. Use your calculator, it's 729. And that's A. And then B, the probability, there'll be 1 out of 729, because only one code is the correct code, and then there are 729 options. So use 1 divided by 729, which is 0.001, and then the probability of selecting the code, the not selecting the correct code, that'll be 1 minus 0.001, be 0.999, because if the chance to get this thing right, it's 0.001, and then the chance to not get this right would be 1 minus, because they are complementary events. So that's the answer for this one. Okay, that's chapter 3. So you just need to know how to find the probability, also including the fundamental counting principle. Chapter 4 is about the probability distribution. The first thing is discrete or continuous. Well, discrete will be something can be counted using whole numbers, and continuous means the number can be anything between a range. So the time, obviously, that's a continuous variable, because it can be anything between a range. And then, okay, so I have to, the B, it's the number of fish caught during a fish and tournament, then that's discrete, because fish, you can count the fishes 1, 2, 3, 4 fish. There's no 3.01 fish, right? It has to be a whole number. And then the height, it's continuous, since same thing, it can be anything between a range. It doesn't mean it has to be a whole number. And then the time required to download a file from the internet, it's again a continuous variable, because it could be 3 seconds or 3.01 seconds. So it can be anything between a range. And then the number of statistics students now reading a book, that's discrete, because we have only 2 or 3 or 4. There's no 4.5 students. Okay, so that's 4.1, discrete and continuous. And then the next question is about probability distribution. So the probability distribution, just as we showed in chapter 3, it's actually the relative frequency. So for 0, we have 229. So 229, it's the number of people, households have no computer, and the total, and then you divide by the total number. So 299, oh sorry, not 229, it's 299. 299. And over 299 plus 280 plus 92 plus 20, just add the all the numbers as the denominator is how many total people's households surveyed or involved in this study. Okay, so this is the number, the answer for 0, that's probability 0.433. It's 299 over 693. And then the others are the same way. You just use, say for example 1, use 280. So 280 over 690, sorry, just a second. Okay, so it's 280 over 691, that'll be the 1, and then 92 over 691 will be the answer for 2, the probability for, and then for 3, that'll be 20 over 691. So the same way to do the problem. Okay, so this problem is similar to the last one, but this time you're given the probability. You need to find the missing probabilities. Just use 1, subtract 0.28, subtract 0.25, subtract 0.25, because the sum of the probability distribution, the probability should add up to 1, like 100%. So if you're given the rest, and then just use 1, subtract the rest, that'll be the missing one. Okay, this is binomial. Binomial probability distribution, because we have, for every outcome, there are 2 outcomes for every event, either a male or a female for every birth, and then it's repeated 10 times. So there's 10 birth, so n it's 10, and then the probability of success, So we're talking about a boy. So a boy is a success. The probability of a success, it's equal to 0.5 because here it says equally likely. So that's why it's 0.5. And we're looking for the probability that x is equal to exactly 4 boys. Okay, so use the binomial calculator. I couldn't show you the StatCrunch because this app I'm using to record, it does not let me to open StatCrunch, but you can use StatCrunch to fill those information. So n is 10, p is 0.5, and then you are looking for probability of x equals 4, and then find the answer. So it's 0.205, the answer. Yep, okay, let's see the next one. This is also binomial. A survey, there's a yes or no question. Either you favor building a power substation in the neighborhood or no. So as long as you can recognize the binomial distribution, you know how to do the problem. Just use the binomial calculator. So here n is 14 because 14 students are chosen. The probability of a success, which means they favor the building the police substation, it's 0.72. It's given here, and you're looking for the probability that exactly 5 of them will favor the building of the police substation. Again, use binomial calculator. So answer is 0.004 if you use your binomial calculator.